Good day, everyone, welcome to GeoTutors. Okay, on today's episode, we are going to prove our two-layer seismic refraction time. Good. And it starts with finding the distance. Okay. So I've explained in former videos that your wave at the source can move in this direction horizontally or in this refraction direction towards the geophone. Okay. So source, geophone, these are distance in between. Now, this is a layer. These are second layer. These are first layer. So first layer, second layer. And between it, we have distance Z1, Z1. So first, our horizontal distance or travel distance, I'll call it travel distance, is SA, right? This distance here, plus AB plus BG. Okay. Now, since based on because of horizontal refractors are equal, horizontal refractors are what? Are equal. What are the refractors? You can say SA and BG. These are horizontal refractors. So this SA is equals to BG. Then we have two SAs, SA and SA. So, yeah, so our travel distance will be what? Will be giving us 2SA plus AB. Good. Now, the next thing is from this triangle SAP, from triangle SAP, SAP, we have theta C. So, and here is Z1, right? From here, we're just bringing the triangle out of it. We discovered that what? Cos theta C is equals to adjacent, which is Z1, over what? Hypotenuse, the longest side, SA. So we say that what? SA is equals to what? Z1 over what? Cos theta what? C. Good. So we want to way to represent AB also. So that will make us to now consider the direct arrival movement, which is this movement here, where we say that what? Let total distance be equals to x, which is equals to SP plus what? PQ plus what? QG, right? So since PQ is equals to AB and SP is equals to QG, so X will now become what? I see SP from here to here is something as what? QG. So that I'm saying here. And PQ equals to AB because PQ and AB are the same length. We have 2SP plus what? AB. Make AB the sort of formula. We have AB is now equals to X minus what? 2SP. Like you're taking 2SP to this other side, okay? And you have AB left. So AB is now equals to what? X minus 2SP. Now, what is SP? If you look at this guy here, this same triangle, discover that what? SP can be represented, you have SP, you have Z, and you have theta C, and we have A. So tan theta C will give us what? Opposite, which is SP over what? Z1. So we say SP therefore is now equals to what? Z1 tan theta what? C. So now write what? AB is equals to X minus 2 what? Z1 tan theta what? C. What is tan theta? Tan theta is what? Sin theta over what? Cos theta. So we have AB is equals to X minus what? 2Z1 sin theta C over what? Cos theta what? C. Good. Now we're going to now substitute the value of what? SA and AB inside the travel time equation. So our travel distance is equals to 2SA over AB. So but travel time will be what? 2SA over what? V1. Because SA is still in velocity 1. It's still in layer 1. So that's the velocity there is still V1. But AB is now in the second layer. So the velocity that will be for AB will be what? Velocity what? 2. Okay, so now let's substitute our in our travel time equation. So SA became what? Z1 over cos theta c. So 2 over V1, right, times what? SA. 2 over V1 times SA, which is Z1 over what? Cos theta what? C, plus AB. Our AB is now what? X minus what? 2Z1 sin theta C over cos theta C, everything over what? V2. Okay, good. So our travel time now becomes travel time T is equals to, we have 2Z1 over V1 cos theta C, okay, plus X over V2. So I'm going to separate this guy since this is numerator. So X over V2, then minus 2Z1 over sin theta cos theta C over V2. Okay, minus 2Z1 sin theta C over V2 cos theta what? C. Good. So we're going to factorize now. So let's bring X over V2, then write everything all over again. 2Z1 over V1 cos theta C minus 2Z1 sin theta C over V2 cos theta what? C. So let's factorize. What is common in both edge? What is common here is what? We have 2Z, have it? 2 is common here, 2 is common here. Z1 is common here, Z1 is common here, right? And we also have cos theta C, right? So, but so that we can factorize completely, we also factorize V1 out of it also, even though we now have V1 here. So that when we now do this, so this guy now and this guy, since everything can be found here, we have 1 minus 2Z1, 2Z1. So what is left in this place is what? V1 cannot be found here, so it will be in the what? In the numerator. Okay? We have V2 here, right? So we'll still write it left because this there's no V2 in this stuff. Then what is left is now what? Sin theta C, since we don't have cos theta C in this place. Now recall that for our sin theta C, which is our incident angle, is equals to the velocity of the first layer divided by the velocity of what? The second layer. Okay, so we replace V1 over V2 with what? So our travel time will now become X over V2 plus 2Z1 over V1 cos theta C, whole bracket, 1 minus sin theta C, sin theta C. Okay? And what is sin theta C, sin theta C? That is what? Sin. So we know 1 minus sin square theta is equals to what? Cos square what? Theta, right? So we now say, recall that cos square theta equals to what? 1 minus what? Sin square theta. You know sin theta is sin square theta. So now we write T is equals to X over V2 plus 2Z1 over V1 cos theta C times cos square theta C. Okay, so our final answer will now become X over V2 plus 2Z1 over V1 cos theta C. Cos square theta C will now remain what? Cos theta C. So this is our travel time for what? Not big C, subscript C. So travel time for our 2 layer. Good. Thank you very much for watching. Kindly subscribe to our videos and recommend it to your fellow friends. Thank you.